Hello guys, welcome back. In this video, we will talk about the priority queue. So priority queue is a heap data structure in which we push the element and pop the element according to some priority. For example, if we have a vector and if we want to push some element like 1, 3 or 26, 5, 4, then the element we can set the priority. The element having the higher numerical value will having the higher priority. We can set the value according to our requirement. For this case, let's the element which having the higher numerical value having the higher priority. So it follows the maxi property. It will be stored as a heap data structure like 26, 5, 4, 3, and then 1. So the element having the higher priority will be at the root of the root of the tree. So whenever we will pop the element from the priority queue, then the root node that is the higher priority that is having the higher priority will be pop out. And and when the 26 will be the pop out, then the second next priority element that is 5. Then next time when we will pop the element, then 5 will be popped out. Then 4, then 3, then 1. So it is not generally a queue. Okay. So and we can also have the priority maximum priority of the element having the smaller value. So that is why it is called the priority queue, because we can set the priority by our requirement. Okay, let's discuss how the priority queue is defined in STL library and how we use it. Okay, let's discuss the code. For using the priority queue, we include the header file of queue, because in the queue header file the priority queue is defined. So for using the priority queue, we have the priority queue keyword, and we define what type of element we want to store in the priority queue. So for example, we want to uh, store the int, then we can define like this. Let's have a vector which contains some element. So let's we have an element 16 or 23, and then 15, then 12, then let's say 23. Okay. And we want to insert the element in the priority queue. So we will run the loop from I to arr dot size, and we push all the element of the vector to the priority queue. So for inserting the element, we use the push function. So simply we push the element. Now we want to check how the element is stored in the priority queue. Then we will pop the element and we will check out the priority of the elements. So until the priority queue will not be empty, then we continue popping the element. Before popping element, we will print the element which is print by the top function. So whichever element will be at the root of the tree, so will be print out, and then after printing we will pop the element. Oh, okay. If we will run our code, then we will see 23 is the highest among all these values. So 23 will be print first, and I have inserted 23 two times. So take let's make it 27. Now let's again run the code. So we see 27 is the highest among these values. So 27 will be pop first, then 23, then 60. So it is printing in the descending order. If we want our priority to set maximum, if we want to set the maximum priority to the element which is having the smaller value, then we can simply make a little change to this. We will pass the vector of it, because uh, we are applying the priority to the uh, this is a priority vector of int, and we have to pass the comparator. It is inbuilt comparator which is defined as the priority greater int. So what does it do is it makes a min heap, and In the min heap, minimum element is at the root of the tree. So the element having the smaller value will be the pop out first. So now it is arranged in the ascending order. Okay, element having the smaller value will be at the root, so it will be pop out first. Then the second smaller element, then third, and so on. Okay, so if it is the priority queue of the int, then we have the inbuilt comparator greater, and for string also this will work. But let's say we want to compare the two objects. Let's say we have the two student and we want to compare the two student. How we will compare the two student? Or let's say we have the two car objects, then how we will compare the two car objects? And we can compare the two objects on the basis of different properties. So how the priority queue will set the priority to that objects? So in that case, we have to define our own custom comparator class. So and we can set the priority according to our own requirement. So let's discuss how the priority queue is work on objects. So let's make the class of the student. So let's make the class of student, and class student having the two attributes, which is name and one is age. And we will make the comparator to initialize the object. Okay, and okay, string, it is a smaller s, and then we set this name is equals to name, and this is equals to age. Now what we can do, before pushing the element, let's try to push the object of the student to the priority queue. So let's make another vector for storing the names. So let's say says Seun, Ayaz, no, says Sadik. Okay, so let's make the object of student. We'll make student s, and we will pass the name, that is name I, and then age from the vector arr. And what we will do, we will push the object s. Then we can see it is showing the error because priority queue don't know uh, that we are inserting the student object. It does not recognize the student object. So we have to define here vector of student, and now our data type is student. We have the student values, and here also greater int will not be work because now our elements are student objects. And now we have to define our custom comparator class here. So we will make the custom compare class. Okay, so let's make the custom compare class. So we will make the custom compare class. Okay, and custom compare class, then we will define, we will overload the operator. We will use the operator overloading, and we will overload this operator, and whenever two student will be compare, then how we want to compare them, we have to define it. So let's say we want to compare two students on the basis of their name. So what we will do, we simply return student s1 dot name smaller than s2 dot name. Okay, now here I am printing only the name. name of the object. So now let's run the code. See, now here I am using the smaller sign, smaller than operator. So it will use the max shape. So the element the name which is lexicographically greater than any other name will be at the root. So Shivam is lexicographically greater than all other names. So it will be print first, then Saj, then Sadik, then Ayaz, then Anup. Okay. If we will reverse the operator to greater than, then it will follow the min heap property. So alphabetically smaller string will be appear first. So Anup will be appear first, then Ayaz, then Sadik. We can also compare on the basis of the length. So if we give s1 dot name dot length, and then here also length, then it will be compared on the basis of the length. See, the name as having the smaller length will be appear first. It is still using the min heap property. So the smaller length string will be at the root of the tree. Okay. We can also make the priority on the basis of the age. So the student having the smaller age having the higher priority. So the smaller age will be appear first. So let's print the age here. See, the smaller age value will be appear first. So in this way we can make our own custom compare class, and we can pass this to the priority queue, and in this way we can make the priority queue and make use of it. And it is very useful in a programming, because many times we need to make our custom compare class, because it is not necessary that we are inserting only the integer string or predefined value to the priority queue. So we can insert any objects to it. Generally priority queue we insert the objects only, and we need to make our own custom compare class in that case. So in this way we can make the custom compare class. Okay.